legacy attack stuff. But, I'll mention some cool attacks from white hat data that we've sanitized and stuff to try to make it Shakacon-like. But this one's going to be a lot of information for you web developers out there, from the expert, Jim himself. He will not call himself an expert. But yep, I'm Johansen, Jim Manico, who we are. I'm born and bred hacker, kind of turned into management, the dark side.
Demoted to management.
Demoted to management, right? Yeah, so I'm building a team of application security professionals instead of being one. I still get to do some cool research. But yep, and Jim's here from Kauai. So he's the local. He taught me the Shakacon, the proper Shakacon way, or Shaka. This is the tourist way. This is the local way. Keep working. Keep working on it. All right, go. Want to go into who you are, why we should listen to you?
Sure. My name is Jim Manico. I'm the VP of Security Architecture for White Hat Security. I provide a lot of the training for White Hat, and I'm also a volunteer for the OWASP Foundation. OWASP is the Open Web Application Security Project. A lot of what I learned came from OWASP, and really happy to bring this to the Hawaii community. My focus is, again, defensive coding. I'm not a traditional security guy. I'm a software engineer. I've been building websites for almost 20 years now. And after watching my stuff get radically hacked day in and day out over the last couple of years, I was forced to learn how to build a secure web application. Really excited to get to share some of these techniques with you. A lot of the information that I'm going to talk about is stuff that you've seen in the industry before. We've talked about parameterization, and we've talked about output encoding for XSS. But with respect, I believe that a lot of the information in the industry now is not it's not complete enough. It's either inaccurate to some degree, or we're defending at the wrong layer in the architecture, or there's all these edge cases. And when security people talk to developers often about secure coding, it's almost always a fail. So I want to try to talk about this from a developer point of view, with the software engineer lingo, and I encourage you as security professionals to copy that as much as you want. It will help you communicate these issues to developers, because culturally, philosophically, there is a major disconnect between security professionals and developers, and it's a radical disconnect. And until we can bridge that gap in some way, we're never going to have secure web applications. So that's my goal here, is to help us bridge the gap. It's not a competition attacking defense, it's working together attacking defense. With me,
Maybe at the end of the present. So this is white hat for anyone who saw Jeremiah's presentation early on day one. You got a good feel of what we do. This is why you should listen to us. We've got a pretty good pool of data. Our 2011 report is going to come out next week for those of you interested in any of our stats. It's really cool. We're just hacking websites day in, day out. We're over 8,500 customers, so this is all we do day in, day out, right? So kind of what Jim was talking about, right? Instead of working against each other, we have to work together as the good guy hackers, right? Because who has the harder job? Right? It's pretty obvious that the defenders are always going to have the harder job, right? Okay, go defend this entire application, every piece of user input, every piece of data storage has to be dead on perfect. Attacker, ooh, look at this one thing that they forgot, right? Ooh, look at this one little hole that I found in some obscure site that just happens to have access to the same database as their flagship application, and boom, owned, right? So this is kind of why we're here and why we're trying to focus a little bit more on the defense.
And if I may, when you think of the difference of the work it takes to be a good attacker versus a good defender, I think it's radically different. Attacker, you grab some Metasploit, you point at some cool things, and things start to break. I know it's more difficult than that when you're doing advanced exploits, but in my opinion, really, even savvy attacks, it's doable. It's an achievable thing. Now, to be a good defender, you need to understand how to do database design, database application development, web application caching, web development, HTML, JavaScript, advanced jQuery design, and I'm just getting started. The things to learn is so massive, and it's tough enough for us as programmers to get the freaking application working in the first place, and now we have like 20 new defensive techniques to add. It is a huge amount of work. and it's very difficult. And the standards that are emerging to help us defend web applications, they're not good enough. Oh, the frameworks, they're pretty insecure too. Oh, the languages, they're pretty insecure, and they're missing a lot of the APIs that we need for good security. Where there's so much against us, and then we're doing all this work, we're building this defensive application, we're spending months and months doing this work, and then some hacker can hack a toaster, and he gets accepted to Black Hat, and the elite defenders get rejected. So to quote Batman, you know, what kind of world do we live in where all you attackers get our defenders pressed? What's the deal?
You're the defender we need. So some of the things we're going to talk about, this is a pretty short time slot, right? We did 2 full days of training the past couple days here about this stuff, and we just scratched the surface there. So this is going to be the drive-by defense shooting here, right? So some of the most prevalent ones that we see all the time: cross-site scripting, session management vulnerabilities everywhere. Cross-site request worker is pretty dangerous, and a lot of people aren't doing it right. SQL injection, even though it's reducing in number of vulnerabilities, all you need is that one, right? Any of these major breaches, all you need is that one, right? So that's what we're going to talk about. Some of the defense techniques for these vulnerabilities, right? The output encoding and proper input handling of cross-site scripting, parameterized queries for SQL injection, and tokenization.
And the key thing here, a lot of security professionals, what do they say is the main secure coding technique? They say, oh, you do input validation, and everything's good. And you can build a secure web application with 0 input validation. That's a network security kind of thinking. Real secure coding is not input validation at the perimeter, it's defense deep within the code. Access control built at your back-end data access object layer. Output encoding contextually, anytime you hit a parser deep in the application. Tokens that are contextual to individual features. You need to turn some tokens off and turn some tokens on. It's not just flipping a switch in the configuration of your application. So the truth is, really good defense of web applications, it's really complex. It's not just input validation, it's way more. It's protecting data within the application. It's protecting your data at every parser boundary deep within the application. And that's the opposite, I think, of network security. And it's part of the gap that we have between security professionals and developers, I submit with respect.
So we're going to start with SQL injection. We think that's probably the most important one that we always say, if you're going to tackle one thing first, if you're going to try to get rid of every vulnerability on your website, but just pick one of those vulnerabilities and get rid of them, SQL injection is the one to pick. Everyone knows what it is. We're not going to spend too much time talking about it. It's kind of what all the hacker groups out there are running around with automated bots, causing these data breaches, and things like that. I'm just going to set up one attack scenario, right, and then we're going to talk about defending this. So this is an actual SQL query that we saw live, and so pretty simple. Update your users to just the update email address, right? And the email address is what we're controlling. Oh, I want to update my email address, and it's going to be where the user ID is my user ID. I want to update my own email address, right? So obviously this is going to be really some complex SQL injection to dump this entire database. Probably it's going to take some PhD to really do this and figure that out.
Website down. 2 characters, and the entire website is down.
Right, so we're in that email address. Does everyone kind of see what happened there? Take semicolon. Never caught to the where clause. Didn't update my email address, updated everyone's email address to a blank string. So
this is like an update user feature, and again, the user was trying to simply update their email address. The super savvy injection to completely take down this website, as in the website stops working, users can't log in anymore, users can't communicate to each other. 2 characters, website down. Major website. So how do we fix this problem? How do we fix SQL injection? There is only one absolutely certain way to stop SQL injection, and it's not some kind of perimeter device. It's not an appliance. It's not some simple filtering technique. It's the programming technique of query parameterization. Every single web language on the planet has this abstraction. So here we have the PHPDO library, and it's a relatively simple technique. So when you talk about SQL injection to developers, I want you not just to show the advanced attack, I want you to talk about query parameterization and variable binding every single time. This is the developer's language. They have these APIs available. In many languages, you get a significant performance increase. The code is better structured when you do query parameterization, and it's a relatively simple programming technique. Here we see the name and value within the query itself. We have the colon as a variable name as a placeholder. Then we use bind parameter to bind that variable into the query. And then underneath the hood of the PHP PDO library, they'll do contextual encoding specific to that database vendor, and even more important, specific to the state of that database in production. Because escape characters may change. There's so much there's different contexts within a query that need to be encoded differently, and you will never be able to figure that out absolutely in a manual fashion. You need the context of the production database and the back-end drivers that are talking to the database, and the binding API does all that work for you. So we have to, there's no manual way to do this in an absolutely certain way. And maybe one quick aside though, when you're getting numeric input into a web application, oh boy, that's when web application firewalls and input validation is an awesome technique. But it's the string input, no regular expression is really good at completely protecting you from every possible attack. Blacklist filtering, it doesn't work in the long haul. That's why a technique like this, especially for string input, is fundamental to security, not just esoteric web security. This isn't just a theory. This isn't just an idea. This is how you are getting whacked hard today. Look at the Verizon breach report. Look at any major report on data of how the world is getting hacked hard in the last week or two. It's this technique. It's this problem, and this is the solution.
So I think the takeaway, real quick, you know, especially for SQL injection, while we go through the next couple of, that is awesome. Good stuff. Okay. So I think the takeaway through the next, especially through SQL injection, we're going to go through a few different languages who have unique techniques here. But the takeaway is, once this knowledge is in the hand of a developer, it's really no more difficult to do it this way than it is the insecure way. This isn't some obscure technique that we're using. In SQL injection's case, this is just as easy as to write this as it is the hard way.
Where's the boss? We would never drink your word, right?
This isn't work. This is a business term.
So now we're looking at .NET. .NET has a couple different techniques. This is the one that most .NET programmers have available to them. This is .NET-based query parameterization. More of the same. We're binding the variables, name and passwords, a slightly different technique. And here we have untrusted input from the request coming in as well. And so this is what most .NET programmers have available. Forgive me for not having a slide on it. There's even a better technique. This gives me hope, because I don't believe that if we force every single programmer to do a lot of the security manually, it's going to be a rat race that we're never going to win. I agree 100%. So we need frameworks to give us automatic security. That's in my mind, that's the magical answer to security over the next decade or so. So .NET has an abstraction called LINQ, L-I-N-Q. And what it does is you say start query, you give the query, you pop some variables in, you end the query, and then .NET will automatically do the parameterization for you underneath the hood. This is magic. So when you're doing architecture for .NET early on, you want to suggest parameterized queries, or even better, suggest that your developers use the LINQ.NET abstraction, which auto-parameterizes and automatically protects you from SQL injection. Java's easy. Java's got the prepared statement class, what we're looking at here. This is more binding. Even things like this is object query language. This is HQL object query injection. Even more esoteric. And this is used very frequently in Java as well as other languages. So even in HQL, this is a variant of OQL, object query language. This is the Hibernate query language. They have binding as well, because there is such thing. It's much more difficult in SQL injection to weaponize and exploit, but there is object query, HQL query language injection, and this is how you stop attacks of that nature as well.
So the next one's we're going to talk about is Ruby. Just floating around the conference the past couple days, a lot of people have been hating on Ruby. I think Jim's going to continue that.
From a security point of view.
Yeah, so especially something happened recently, right? So go ahead.
So here's the API to query parameterization in Ruby. The problem is that, well, at first I was really a big fan of it because programmers will just talk to this API. They build objects, they delete objects. It's a very simple data abstraction API from a programmer point of view. And boom, everything should be fine. But underneath the hood of this API, what does Ruby on Rails do? Anyone seen this attack from last week? Every Ruby on Rails app in the world right now is pretty wide open if you haven't patched it. Underneath the hood of this abstraction to talk to data mechanisms, they're not doing query parameterization, they're doing string concatenation to manually assemble SQL statements. And last week we saw that that mechanism is fragile, and there are ways to abuse the system to cause SQL injection against Ruby on Rails in a fairly easy fashion. And overnight, every single Ruby on Rails app is now wide open to SQL injection. So even though their abstraction looks like it has variable binding, underneath the hood of that, Ruby is just doing query assembly, which is open to SQL injection. It is a massive problem. I dare say it's a shameful problem. Again, the only robust solution to SQL injection is true query parameterization at multiple layers, both when you write the query, under the hood as a driver talks to the database. You have to do query parameterization in your stored procedures as well. Anyone who says stored procedure and you're more automatically immune to SQL injection, that's totally wrong. You can have SQL injection in a stored procedure as well. So you bind at the query level, the procedure level, and as you call a stored procedure, that's deep security. Anytime you talk to a database, you parameterize your variables.
Is that one of your rules?
Yeah. So Cold Fusion's interesting in that one of the problems of other query parameterization APIs is that you can't parameterize a table name or a column name. Now, there's a technique in programming called sharding. This is when you want to build one query, but you want to use it on many, many different tables because you have different instances for different customers. So when you do sharding architectures, you very often want to change the table name. In Java and .NET, we have to do validation for those table names. But in Cold Fusion, just a neat little quirk, they actually allow you to parameterize the table names and column names. Again, this is just some of the idiosyncrasies about query parameterization that when you talk to a developer in this fashion, they get it and they like it. And so I think this is the level that we want to rise to when we communicate to developers about this stuff. And last, but what? Even Perl. Old school Perl from way back in the day, beginning the dawn of the web. It's got an awesome query parameterization API, and it, like the Perl way, it's simple, it's concise, and it works. So that's how we have to build our code if we truly want to be like total Pono security, complete, robust, fully working, fully valid security. I'm not interested in partial security. I'm interested in at least the theory behind complete security, because I think we need that to survive over the next 10 years. Just my thoughts on that.
So before we move on past SQL injection, because I know all of you now are never going to have SQL injection in any website ever again, right? So before we move on, any questions for that? We're going to kind of flow past. This is like super speed.
So far, so good.
Cool. All right. So I'm going to knock a few out in one vulnerability. With my nice combo here, finish him. So this was found on a kind of social networking-like site that I guarantee a large percentage of people in the room use this social network. No, it's not Facebook. That's all I'll say. And it's going to knock a few of these off in the same one foul swipe, right? So we're going to have some cross-site scripting, some CSRF. Even though when you have cross-site scripting, CSRF protections are pretty much null and void. You can grab CSRF tokens dynamically and add them to your exploit. This just makes it a lot easier when it's also vulnerable to CSRF and supports session management, right? So here's our kind of sanitized post request URL of what's going on here, right? So it's, you have your profile, you can add tags to your profile to make your profile searchable more easily, right? So in this situation, this poor user really likes unicorns, wants to be searchable by unicorns, so he's trying to add the tag unicorns to his profile. So you see down there in the bottom of the post request, in the post body, there's pretty much two parameters. There's some random base64 value, doesn't decode to anything meaningful, but it's unique to you and your profile. And there's a tag that you're trying to add to your profile, right? So the rest of it's pretty much just the headers and everything like that. But you see up at the top, that's actually not the URL that this post request is going to. That's your public profile URL. Do you see some sort of commonality here between your public profile URL and the possible post request? Right? So that base64 value is pretty well known in your public URL, and that it's used in this post request. So who wants to take a stab? What would you try? Web hacker in the room. Brave soul. Anyone?
Where's Potter? Potter, you in town?
All right, I'll tell you what I tried and what worked. Okay, so I'm gonna go to Jim's profile URL. I'm gonna look at his base64 value, and I'm gonna put it in this post request, and I'm gonna make Jim like unicorns.
You got big unicorns.
It's not the Go love. You love talking about the Go love on the Twitters. All right, so this actually worked no problem, right? So then the other problem is that tag was also vulnerable with, this is a DOM event, by the way. This is all the DOM executable JavaScript. It's persistent, the tag stored under profile, right? That tag is also vulnerable to cross-site scripting, right? You got a character limit, pretty easy to get around. You can see my injection there. Script alert, comment out the rest of the line, period, right? So what kind of just happened? So I can, it's pretty much a zero-click worm with absolutely zero user interaction, right? So if I put XSS on your profile to force you to make these requests, that's pretty cool. But I can just go around and write my own script, scrape the whole site for those base64 values, and add the cross-site scripting myself to your website, right? So this is kind of a Sammy worm with zero interaction whatsoever. So one launching point. Pretty unique, pretty cool. It's, just one example from our data here, right? So one more, just kind of cool, weird cross-site scripting, and then I'll let Jim talk about some excess defenses for two of these and why the defenses they had in place were not good. Oh, this poor fake site, right? Just got wormed, it's going to get their login page. So they're doing some login, and these are actually some hex encrypted values, weak encryption. I can actually encrypt my payload the same way that they were encrypting their username and password. I was ignoring the fact that they were doing this over a GET request and the username and the password, and decided to go straight for cross-site scripting. Again, character limit about 15 characters in each one, so I had to use a technique called daisy chaining. Just HTML block / star, where I want my attack to start again, / and it worked. No problem. So they were encrypting and hoping that would be enough, but it decrypted my values, no problem, no encoding, no defense whatsoever. So those are just two real examples from our data of just a little bit different than plain vanilla cross-site scripting, and just going to kind of talk about why their defenses that they had in place didn't work.
When we look at what most of the industry says about cross-site scripting defense, they talk about a technique called contextual output encoding. Remember, when you're accepting input into a web application, early defenders would just try to strip out the bad characters, the big six, less than, greater than, single quote, double quote, ampersand, and slash. And that defense breaks web applications. Here's my main conjecture as a secure coder. You need to be able to handle malicious characters, complete attacks safely, save them, load them, and render them in a way that does no harm to users or your system. So we have to you need single tick. How many Hawaiian names have a single tick in it? And you start blocking single ticks, and you now start blocking people's ability to type in their full names. Same with Irish, O'Malley, O'Shea. So we need to accept dangerous characters. Again, save them, load them, send them to web services, render them in the HTML, and do it safely. That's why the concept of encoding or escaping is so important. We're taking untrusted data that's potentially malicious, and we're converting it into a safe context, a sanitized context, without losing the data itself. So we still have the string, but we're just going to escape characters so they don't execute in the DOM. They don't execute as if they were JavaScript. And frankly, to do this, I think it's even more difficult than cryptography, because every different slot in an HTML document, think of how web application flows. Again, user submits data to some kind of user gets an HTML form, they submit that to a back-end web application piece of code like PHP, that submits that data via SQL to a database. Later, someone loads that data via SQL and dynamically builds an HTML page with all these slots where untrusted data goes. Like you see a web page, welcome Jim Manico. Who typed in Jim Manico? The web developer did, and I did. And now I have to render that to me and other people, and it could be malicious. So in order to protect these endpoints, the place where untrusted data is entered into an HTML document, we want to use escaping, contextual escaping. And based on the different context of display, whether it's an HTML body or HTML attribute, or if it's a cascading style sheet value, or if it's a JavaScript variable assignment where untrusted data flows to, we have to do something different. And so, I have this experience not from theory, but from being a developer. I've had to solve these issues, and so I've put a lot of this knowledge into the DOM-based XSS cheat sheet at OWASP. I helped fix a lot of Jeff's mistakes from the XSS cheat sheet from OWASP as well. Had about 500,000 hits on that. I've also added a lot of this knowledge into the different white hat remediation guidances that we have within our Sentinel service. And so I'm trying to push this out as best I can. So let's talk about these quickly. Once, then I'll do it again a second time. I'm going to move through it kind of fast. Any questions, stop me at any time. So if data goes into an HTML body, between two bold tags, between two H1 tags, simple context, we do HTML entity encoding. If data goes into an attribute, we do a more aggressive entity encoding, attribute encoding. We have to encode spaces, almost every other character except for alphanumerics. If untrusted data goes into a get parameter value, this is just a value within a URL, not the whole URL, just the parameter. We do percent escaping or URL escaping. If we're dealing with a URL in our untrusted data, it's a much more difficult use case. I'll talk about that in just a moment. If you have a widget like TinyMCE, this is a very common widget within web applications, especially administrator consoles. This is a rich text editor where you can bold, you can underline and number lists. And this is a text area replacement. It makes your text area look all of a sudden like a word processor. That submits data as HTML. You tell me, defenders, suppose you have a parameter that's a chunk of HTML. How are you going to sanitize that HTML to make sure it doesn't include malicious JavaScript? Vince, want to write a regular expression for me to help me sanitize all HTML so it's perfectly safe HTML? Not in my lifetime. And so we need a much more robust defensive mechanism to pull that off. And then we'll talk, we need more rigorous HTML validation. We also have all the DOM issues, and we have the whole issue of parsing JSON and the recommendations from the JSON standard. I say that in quotes, the standard itself is incorrect. Also, when we put untrusted data into attributes, there's a limited list of attributes that we can work with in a safe fashion. So rather than say, don't use these attributes, kind of a negative list perspective, I like to say, only use these attributes and everything else is dangerous. It's a more safe approach when doing developer communication. It's charge. There are some contexts that are always going to be illegal. You can never put untrusted data just inside of a tag without an attribute context. That's just there's no reason to do the first one up there, and it's always dangerous. Same here. This is basic. What's this? What would we call this? We have untrusted data landing directly in an eval statement. And you'd be surprised how often I've seen this in code. What would you call this? Or like cross-site scripting as a feature. I actually saw an app where I flagged this as a vulnerability, and the business was like, no, for certain reasons that we're not going to tell you about, we need that. It's required for the system. I'm like, oh, okay.
We're trying to own our users.
I'm sorry?
We're trying to own our users. That's what it is.
Hey man, at that point I'm like, just back away from this, just back away from the bad code and move on.
Click this link for a terminal on our server too.
Yeah,
That's
exactly.
a feature.
There's plenty of other bad code I can look at. If somebody really, they were really holding on to that major, massive vulnerability, dude, don't touch that. I'm like, oh, okay. So here we have the HTML attribute context. This is untrusted data in a simple div ID. We want to use the entity encoding format. Again, we do the encoding where the rubber hits the road, where the untrusted data is being inserted into an HTML document. Not on input, not in the database, but when you pull from a database and are about to put it in a user interface. This is the parser untrusted data boundary. That's the safest and most sensible place to do your output encoding. because you understand the context. I see people do it in different parts of the architecture. It's almost always a design mistake.
The earlier it happens, the more fun I have with it trying to break it, right? There's more steps in between. Okay, how many rounds of filtering are you doing? Great, okay, you're blocking this now. How about if I put a URL encoded less than sign within a URL encoded less than sign, right? Percent 3CC, right? Oh, you did one round of filtering? Cool. Second round, I'm good. Because you're doing your filtering too early. On the way out, that's less fun for me.
I'm sorry to ruin your butt. I'm trying my best to ruin your butt. So there's a flaw in this slide that I put up there on purpose. Why, for super web application hacker, Uber bonus points? I know you want bonus points. You want bonus points, right?
Free car.
What is wrong with this? When I say div ID is untrusted data, even if the encoding is done properly, what vulnerability did I just add to a web application? It's a really esoteric problem. Where's Potter? Potter? He's hiding in the back.
I have a question for you, Chris.
I don't want to call you out. I already did 3 times, but I didn't want to do it. It just came out. Sorry. This is a problem called ID clobbering. So when you're building a rich JavaScript application, all your widgets have a unique ID. When you have an ID in any widget and you let untrusted data drive it, that allows the attacker to clobber other IDs and make modifications in the DOM that the developer never expected. It's really esoteric. There's a reason why ID is not a quote-unquote safe attribute. An ID should always be trusted data, not untrusted from the user. It's just an esoteric weirdness to abuse you. Next slide. So now we're looking at a URL. Make no mistake, when we have untrusted data, this image, when this goes into the image tag, that's just not an image, that's a full URL. And the attacker can manipulate that image to do all kinds of crazy things at this point. Think of Twitter. Twitter has a huge programming problem. Someone tweets a chunk of text. Twitter grabs that chunk of text, parses the text, has to rip out a URL, validate that it's a legal URL, make sure it's not a JavaScript URL, which still to this day pops in most browsers, make sure that that URL is not malware, take that URL, still untrusted, and put it in an href tag so it's a link, and then encode it properly so it doesn't XSS at the time of rendering that URL. And we saw from the Mikey worm, and yes, the Go worm,
yeah,
I'm sorry to bring up Go Love again, man. But no offense to goats, no offense to goats. I was actually teaching a course overseas, and I started making fun of goats and the goat, and they were like, as an Indian, how dare you make fun of the goats? So like, whoa, whoa, whoa. So no offense to the goats. But, where was I? How did I get here? How did I get to here?
Does anyone know the worm he's talking about, or do you just think he's crazy?
It's go look up, it's the Mikey Twitter worm, which is...
It exists, and everyone was tweeting about their GoLove, but they were hacked.
And the flaw was them processing the URL and parsing that properly and making it a link properly. It's tough code. The other thing is malware. Twitter wants to avoid tweets of malware, not to protect the Twitter system, but to protect their users. Responsible thing. So when do you check if a link has malware in it? On input? That's important, but what happens if 5 minutes later, when you say it's safe, the owner of that URL puts malware on it? So you have to do your malware check, not just on input, but also on output. Oh, but wait a second. If you have a tweet with a URL, do you want to do a full malware check every time you render that tweet to different users? That's a major performance problem. So what you want to do usually is you do the check for a particular URL, you do it on like a 6-hour basis on output to make sure that you're up with trends or someone, or if the attacker is trying to slip malware into your URL after the fact. Next slide. HTML input, we talked about this earlier. When you have HTML input from a widget like TinyMCE, no regular expression, no input validation, and for that matter, no output encoding is going to save you. In this case, you want to use some kind of HTML sanitization policy engine written by serious experts. There's the Java JSoup project, very well written and maintained, but it's a little bit denial serviceable. They're using DOM-based XML parsing, which is a bit slow, but it's a good project. We have the anti-SAMI project, not written by a senior developer. It's a good project, but there's some quirks in it. It's not as robust as people say it is. And it's easily deniable serviceable, especially older versions of it. So I'm a big fan of the HTML sanitizer project for Java, written by Michael Samuel from Google. He wrote his own parser from scratch. And I asked him, hey man, this is a complicated code. What do you have, a couple PhDs or something? Yes, I do, Jim. Okay. Okay, so I'll trust your code. And we also have in PHP, the PHP HTML purifier project. So we need something special in this unique use case to stop. Oh wow, I'm going on and on, I'm sorry. Next slide. URL parameter escaping. This is untrusted data in a URL. This is where we have, like this is common in search features. You go to Google, you search, then they come back and say, your search results for the word Apple. Like if you say something like, Apple, I love Macs. And of course you get 0 results. And that was a joke, boys. I'm sorry, I love Macs, I'm sorry, I'm just kidding. All right, it's always easy to mess with you out.
Every time Jim got the little rainbow wheel during training the past couple of days, he's cursing to the gods of Mac.
All right, so here we have a search feature. Someone just did a search on a certain term. The URL was reflected back of what they searched on. So when you take that search term and put it back in the URL, this is where you use URL escaping. This is where you use percent escaping. We used to say, oh, you just URL escape the entire URL and everything's fine, except that URL doesn't work anymore. You can't click on it. So you got to only escape the parameter itself, the parameter value. Let's charge. Now we have a cascading style sheet value. We're going to let the user drive a color in their dynamic CSS file. In this case, we want to do CSS hex output encoding.
I'm gonna interrupt you. In this case, we're gonna not let our users do this, right? Is there any reason to let a user drive CSS style sheets? Probably very, very few, but we see it a lot. But if, in the rare case, the business needs to, CSS content encoding.
This is the problem with cascading style sheet hex output encoding. Even if you do the proper encoding, we have this problem with IE6, IE7, and IE8, 9 in corpse mode. Who still depends on IE6 or 7 within their company? You're in a safe place. I won't tell anyone, I promise.